Hi guys. So this video is for grade 7 math. And the topic we will be doing today is the Pythagoras theorem. This is a geometry theorem which actually is very frequently encountered in all areas of math. It is really, really important, especially in higher classes. Um, and you'll be using it very, very often. So it is quite easy to understand and apply. So hopefully there are no issues with that. So let's start. Okay. So the Pythagoras theorem is one that can only be, so it was derived from the Greek mathematician Pythagoras a really long time ago, and it can be applied to only right angle triangles. All right. So just to recap, a right angle triangle is one which has is a triangle which has an angle of 90 degrees in it. So for example, this is what a right angle triangle would look like with a 90 degrees. Now in this triangle, if I named it as A, B, C, all right, just for future in the future for you to understand, I'm just gonna give names to the sides. So AB is typically called the height of the triangle. So I'm just denoting height by h. BC is typically the base of the triangle. I'm going to denote it by small b. And AC is what we call as the hypotenuse. The hypotenuse is, I'm going to denote, this is HY. The hypotenuse is basically the longest side in the right angle triangle, and it is opposite to that of the 90-degree angle. So you have this 90-degree angle, the side opposite to it will be the hypotenuse. It will also always be the longest side that you get in the right angle triangle. Okay, now what Pythagoras said was he made a theorem referring to the lengths of these sides. And he said that the hypotenuse squared, if I square the hypotenuse, all right, I will get the sum of the height squared and the base squared. So h squared plus b squared. That's what Pythagoras essentially said. So if I had to put it in context of this triangle, AC squared would be equal to AB squared plus BC squared. That's the Pythagoras theorem. That's essentially all that you need to know. So now if I give mathematical values to this side, and I said, all right, this AB, let's say, is 3 centimeters. BC is 4 centimeters. All right, now I need to find AC. So how would I do that? I know AB and I know BC. So essentially my AC would be AC squared would be equal to AB squared plus BC squared, which here is equal to 3 squared plus 4 squared, right? And so that will be 3 squared is 9, 4 squared is 16. So I would get 25. So please remember that AC squared is 25 and not AC. That's a common mistake which people tend to make. And so to find the value of AC, I will then square root of 25. All right, if AC squared is 25, so AC will be the square root of 25, which will be equal to 5. So 5 centimeters is AC. Okay, so this is the most basic example. Let's try and do one more example for better understanding. So if I had another triangle like this, A, B, C again, and let's say I had this base side as let's say 7 centimeters, and this side was, let's say, 25 centimeters. All right, then what would happen is that you again would use your Pythagoras theorem, which says AC squared is equal to AB squared plus BC squared, and then that would give me so then you would substitute the values, and you would get 25 squared is equal to AB squared plus 7 squared. And so AB squared would be equal to, just simply transposing this on the other side, 25 squared minus 7 squared, which would become 625 minus 49, which would give me 576. And the square root would give me of 576 would give me AB. So AB will be equal to root 576, which would be equal to 24. So 24 centimeters is my length here. And so this side will be 24. Okay. So that's essentially how Pythagoras theorem works. This is literally the parallels. They can just substitute one of the sides you'll have to find, and you can, using Pythagoras, you can just use the other two to find the third one using this theorem. A question could also come in the form of a word problem. So if I had to put it in word problem, the most common one is, let's say you have a building. All right, there's a building. I'm just going to draw a 2D figure. So let's say this is a building and you are standing here and there's a ladder leaning against the building. So this would typically be your ladder. And you need to find, you could either be asked to find the height of the ladder or the height of the building or the distance between the building and the ladder, which would be this distance here. All right, so if I had to name this triangle now, I get a triangle like this, A, B, C. All right, say what was given, the height of the ladder was given to me as, let's say 13 centimeters. Obviously now a height ladder is not going to be 13 centimeters, but this is just for understanding. And let's say the height of the building was 12 centimeters. And so then what would be the distance between the building and the ladder? And that would be a really good, the most common question that you kind of get. And so then again, you'd use your Pythagoras theorem. So it'd say AC squared is equal to AB squared plus BC squared. So 13 squared will be equal to 12 squared plus BC squared. And so 13 squared is 169, which will be equal to 12 squared, which is 144, and plus BC squared. So BC squared will be equal to 169 minus 144, which will become 25. And so BC is equal to root of 25, sorry, and which would be equal to 5. So this is the most frequently encountered case of word problem. In any other word problem, all you need to do is just kind of try and figure out the right angle triangle and then apply Pythagoras. Just imagine the situation in your head and figure out the Pythagoras triangle and how you'd apply Pythagoras theorem there. Please remember that this does not work for all triangles, only right angle triangles. All right, don't see a different triangle and use Pythagoras theorem. That'll be incorrect. Also, a useful tip for the Pythagoras theorem would be, because you have to use squares very often, if you can try and learn the squares of until at least 15 or 16, it would really help. By common logic, of course, if you had, one for at least 1 to 10 would be really simple, but even after 10, 11, 12, 13, 14 squares, it would really help. The ones people tend to forget are, for example, 15 squared is 225, and 16 squared is 256, 17 squared is 289. All these values will really help if you just know them by heart, because your Pythagoras will go a lot faster. And one last concept that's there in this chapter is that any combination of sides which agrees with the Pythagoras theorem. So for example, we found 5 as the value here, right? Which means that 5, 12, and 13, all right, they fit into the Pythagoras theorem. They obey the laws of the Pythagoras theorem. So any 3 of these sides together will be called a Pythagorean triplet. So very common Pythagorean triplets include like 5, 12, 13, or 3, 4, 5. These are all very common ones. 7, 24, 25. All of these, they are all called Pythagorean triplets. All right. But yeah, so any 3 sides which obey the laws of the Pythagoras theorem, those will be called Pythagorean triplets. And that is all the Pythagoras theorem is about. It is a really, really simple and easy theorem to apply, which is used so often in different fields of trigonometry, geometry, things which you learn in later classes. So that's it. If you have any questions about this, do put it in the comment section and I'll answer it. Thanks, guys. See you.